So, good afternoon. Today we came to our plumbing class day 16. So, today we will be dealing with drainage systems. Okay, these many days we were studying about the plumbing supply system. From today onwards, we will deal with. I mean, yesterday onwards it started, right? Because we were dealing with stormwater drainage. So today mainly we are focusing on the foul sewage, okay, foul water system, okay, and its pipe sizing of drainage, pipe, pipe sizing of drainage, drainage pipes, okay. So we are dealing with foul water drainage system and its pipe sizings, okay. So today we will be dealing with some questions, how to find out the pipe size, and we'll be seeing different tables. Okay, tables related with National Building Code. Okay, so if you get a question, if you want to, uh, size the pipe mainly for drainage, uh, we'll be seeing about it. Okay, so without wasting much time, I will just share my screen. So we'll be dealing with foul water drainage in building as well as this designing designing part also will be taken today itself. Okay, designing in the sense how to find out the pipe diameters. Okay, that's also will be taken. Now, uh, initially we'll be having just small descriptions about what is this different, you know, you know, drainage. Okay, definitions. We can just see about its different definitions. Then we can focus on the designing part. Okay. Now, first coming to drainage, you know, just we can see about some introduction. Just I will dictate this. Uh, so you listen to me carefully. It is a simple thing only. Just some introduction about the drainage. Okay. So generally, all the wastage water from all the floors are being driven out from the building through the main drainage pipes, and that the main pipe is connected to the municipality lines. So mainly in cities and towns, okay, where people mostly live. In such cases, what we do is that when we give supply, automatically there will be drainage, right? The water from the toilets and from the kitchen and all those places has to be drained out from the building. So normally, from all the floors, the water is being driven out from the building through the main drainage pipes only. So the water, the waste water will be driven out through piping only, pipe system only. Okay, and the main pipe is connected to the municipality line. So it will be the main pipe will be there will be many branch pipes from individual floors and from toilets and from fixtures, and that will be connected to the main pipe, that the main pipe will be connected to the municipality line or municipality drainage, main drainage municipality lines are there. Okay, it will be connected to that. Cases, the places like here, if you have individual houses, you will be having a separate septic tank and a soft pit or a wastewater pit so that you can, collect the wastewater in the appropriate pits, appropriate tanks. Okay. In the case of municipality lines or sewages, you can, in that case, you can connect your main pipe from your locality or from your house to the uh, municipality line. Okay. Now, the main line is located near the ground floor. Okay. Uh, so the main line will be located near ground floor only, correct? Because everything has to be collected and to the ground only it will be connected to the municipality line. The wastewater from the entire floor is collected at the ground floor manifold, okay, from the gravity and is passed to municipal main collection. So yesterday I have shown you about the stormwater also, how I have just designed the stormwater. So initially stormwater also I have just initially the water was there in the collection chamber. From the collection chamber only I have given to the manhole. So here also what you have to do is that here the wastewater has to be directly connected to the manhole. From the manhole, water that is reaching through the manhole will be by the gravity only. So you have to give an appropriate slope, okay, in order to reach the manhole. Okay, and then after the manhole, then only pass into the main municipality connection. Now, the wastewater from the basement are collected at the lower basement sump pitch and pumped to the ground manhole. From this stage is driven out. So, here, there might be toilets. So in that case, what happens is that, the pit, you have to see, you have to make a separate pit for that. Because normally, the pit is the ground floor, correct? So if it is in below the ground floor, how to, the water won't reach to from bottom to top, right? From down to top, it won't reach, correct? So in that case, what you have to do is that you should have a separate tank or wastewater pit, depending upon the number of toilets. From there, what you have to do is that you have to pump it, okay, to pump to the ground manhole, ground floor manhole. You can discharge into that manhole. From there, you can driven it out. Okay? So that is in the case of basement. Okay, if it is below the ground level, you have to make a separate tank. From there, you have to pump it to the main manhole. Okay, in the ground floor. Now, outside of the building, there is a final inspection chamber, and that chamber connected to municipality manhole. So there will be different small manholes will be there. Then it will be connected to the final inspection chamber. Then from there only, connected to the municipal manhole, okay, municipality manhole. That will be a government manhole only, okay. So there will be small manholes around the building, and from there it will be collected and it will be given to the FIC, final inspection chamber, and from there, it will be collected to the municipality manhole. Okay, all the water flows to the main sump through FIC only. Okay, so the water flows to the main sump. Okay, main sump of this municipality through final inspection chamber only. Okay. Inside the building, we have gully trap, manholes, sediment collectors, sand trap, etc. according to the design of drainage system. So, depending upon the application and depending upon the flow and the type of water that is coming through the pipe, we have different traps like gully trap is there, manholes are there, sediment collectors, sand trap are there. So depending upon different localities or countries. So if you are going to some Middle East countries, sand trap because and all those things will be there, and the sand will be deposited in this there in the or collection chamber. Okay, so in that case, what you have to do is that you should have a sand trap also, okay, so that we can filter it, and then the water can be passed. So it depends upon different application. Okay, always that won't be used. Okay, and gully traps will be there. Okay, gully traps mainly will be it's like a trap only. What is the meaning of gully trap? Helps to it acts as a sealant. Right? It acts as a sealant. So sealant in the sense like you know, from the toilet the water is been flowing through the pipe. Okay, so that will be collected to some tanks only. Right. So there's a chance of this foul smell to our toilets. Okay. So what we do is that we can keep gully traps in between it. So that will be acting as a sealant. Okay. That will be acting as a sealant so that it can stop the to come back to the uh, toilets. Okay. Now design criteria. Okay, these are all basic things. Okay, just I am explaining. Basically, drainage system can be designed based on the provision of piping arrangement to carry out the building sewage system to public sewage system without affecting the environment. Okay, so the drainage is depending upon the provision of piping arrangement. Okay, there are two basic systems of plumbing for building drainage. Okay, there are two basic systems that we can implement when we are designing a plumbing line. Okay, First one is called the single stacked system, and the second one is called the double stacked system. Single stack system is there, double stack system is there. Okay. So what do you mean by single stack is that, simply explaining, like, the both is soil waste and the wastewater. So there are two types of waste which comes out from our building, okay, or from our toilet. That is the wastewater from the toilet and the soil waste or a solid waste from the water closet. That will be counting as a separate line. The water that is coming out from the water closet is being separated, okay, and all other water will be calling it as wastewater from kitchens and washing and toilet, bathing, everything will be taken separately. So in a single stack system, what happens is that in this system, the plumbing, in the system of plumbing, the waste from all soil appliances are connected to one main soil stack, which is connected to building sewer. All types of soil and waste appliances are completely ventilated through separate ventilating pipe stack. Thus, it contains one soil cum waste stack, one ventilating stack. So, what is the specialty of this is that both the soil as well as the wastewater is being collected in a single stack or a single pipe. From that pipe, ventilation will be given. A separate ventilation also will be given. So whenever there is a pipe connection, waste pipe connection, there should be a ventilation also will be provided in that pipeline. Okay, and the specialty of single stack is that both the soil, which means the water on the waste that is coming out from the water closet, and the normal water wastewater that is coming out from the toilet, both are is being given to the one main soil stack. One main soil stack. All those are connected to one main soil stack. Okay, with one stack. The stack means per pipe filling. Okay, vertical pipe filling is called a stack. Okay. So the single stack system shall be prepared where the planning of a building provides for a suitable grouping of all soil and waste appliances and are commonly taken to building sewer and further to public sewer. So this single stack, it will be prepared in planning where both the soil as well as the waste is connected to a single stack. From there, it is taken to the building sewer and further to the public sewer. Okay, so single stack, as the name implies, both the soil waste or the waste that is coming out from the water closet and all other wastewater coming from all other areas in your building is taken through a single stack or a single pipe connection. From there, it is commonly taken to the building sewer and then further to the public sewer. Okay. Now, this is one pipe system. Okay. Similarly, with this, I will show you another picture of it. Some basic you may not understand. So, in one pipe system, soil and waste fittings are discharged into one common stack with a common vent pipe. This is the meaning of that one stack or one pipe system. Okay. So you can see here in one pipe system, it is a little more clear picture. Soil and waste fittings are discharged into one common stack with a common vent pipe. So you can see here. Imagine this is a 1, 2, 3-story building. Okay, and you can see here this is a sink, this is a wash basin, this is a water closet. Sink, bath, tub, wash basin, water closet. Okay, so you can see here the pipe. This is just a pictorial representation only. You can see the pipe. The pipe connection is being taken like this. Okay, and it is being both the water closet waste as well as the other toilet fixture waste is being taken to a single stack. Okay, this is a main supply waste pipe only. Main supply. Waste pipe only, and this is the main vent pipe, MVP. Main vent pipe only. This is the waste pipe only. Soil waste pipe. Main soil waste pipe. Okay. So you can see here, these lines, the discharge of water from all the fixtures is directly taken to only one single stack. Okay. You can see it is connected to a single stack only. And the ventilating pipe, okay, or the main vent pipe, you can see it is taken separately. It is taken separately. So soil and waste fittings are discharged into a common stack, the common vent pipe. So you can also have a common vent pipe. It is not separate vent pipe. You have a common vent pipe. This is called as one pipe system. Okay, the drainage will be going to one stack, and the vent also will be common vent. Okay, so this all this water will be collected and will be given to the building drain. Okay. Now in a double stack system, so we heard about single stack system and double stack system. So what do you mean by double stack system is, in this system of plumbing, the soil and the waste stacks are distinct and separate. Okay, this will be distinct and separate. The water that is coming and the soil waste that is coming up from the water closet and the wastewater from all other areas except this water closet is distinct and separate. Okay, the soil stacks shall be connected to building sewer line, and the waste stack shall be connected to building sewer through a trapped gully. Okay, or a gully trap. Okay, in order to avoid smell and all those things. Okay, all traps of soil and waste appliances are completely ventilated, each through separate ventilating pipe or stack. So all the traps of soil and waste appliances are completely ventilated. Okay, so we have to give vent. Okay, through a separate ventilating pipe. So here also we have to give a separate ventilating pipe for all the fixtures and traps. So thus it contains one soil stack and one waste stack and two ventilating stacks. One ventilating stack for soil stack and one ventilating stack for the waste stack. Okay, stacks are the vertical pipes. Okay, so here in double stack system we will be having two separate pipelines, one for soil as well as one for waste, and two different ventilating stacks, one for soil and one for waste. So the double stack system is advantageous where sunlight or wastewater from waste appliances can be dealt separately. So this is more advantage so that we can deal with the soil waste separately and the wastewater separately. Okay, and and you can use it for landscaping and for closet flushing, etc. So that this wastewater can be used for recycling or something like that. Then again, it can be used for landscaping and flushing, etc. If you are mixing this both, that won't happen. Unless you have to do STP and all those things. Right? So here you can just separate it into both and you can deal each separately. Okay? The basic idea of the system is to separate the soil waste getting mixed with the wastewater inside the building. So the main basic idea of this double stack system is to separate the soil waste without getting mixed with the wastewater inside the building. So we should not come in contact with both. That's why we use double stack system. So mainly we will be using this double stack system. Okay, that will be very advantageous and easy for further maintenance or some servicing also. Okay. So in two pipe system, soil and waste stacks are separately provided with its own vent. Okay, and then show you it. So two pipe system, soil and waste stacks are separately provided with its own vent. So you can see here, wash basin, bath, sink, and water closet is given separately. So all these sink, bath, wash basins, all these lights are taken separately and given to a common stack, except water closet. In this water closet, separate lights is being taken. You can see separate line is being taken. So for soil waste, separate main soil pipe is there, main vent pipe is there. Okay. So in this case, main waste pipe is there, main vent pipe is there. So these both are separate. You can see here. Separate vent pipe is there, separate waste pipe and soil pipes are there. Okay, that is called as two pipe system. Normally we use two pipe system. Now these are some of the pipe sizes for connection from sanitary fixtures. Okay, so these are the minimum drain pipe sizes. Okay, now I will show you those from the NPC also. Okay, so this is water closet main the normal drain minimum pipe size is 110, wash basin 32. But in the usually when I design, I will put a safety factor and give minimum of 50 outer dia. Okay, outer dia 50. Okay, for the wash basin. Okay. So if there is some, 32 is the, is the minimum pipe diameter or the diameter from each fixtures. Okay, but still as a safety, okay, I used to give 50. Okay, but this 32 might be enough. So shower 40, bathtub 40, washing machine 40, bidet 32, kitchen sink 40. Kitchen sink usually I give 63 mm, 63 mm. Urinal 32, clean floor, that the floor trap will be, you know, so the outlet of the floor trap usually MDC is 75. Okay, so we can give 100 also. Okay, floor trap outlet can be 82. So that so whatever fixtures that drain should be connected to whatever fixtures are there inside your toilet that has to be connected to the uh, floor trap. Okay, floor trap. Okay. Sorry. The next one, depending upon the pipe size, the slope will be different. For a 200 mm pipe, the slope will be 1 is to 120. For 120 meter length, 1 meter is the slope. So if it is 160, 1 is to 90 is the slope. 110 mm pipe, 1 is to 60 is the slope. 32, 1 is to 50, 50, 1 is to 40. According to this, the slope differs. Okay. So I was saying about this, drain pipe, right? So I will show you a sample picture of it. Small house. So, so you can see here. So imagine this is a toilet only. This is a toilet. This is a wash basin. This is the water closet. There's a shower also here is there. Because of the drainage, you can see. Okay. So in this case, you can see here. This is the floor trap. Every fixtures has to be connected to the floor trap. You can see here it is connected to the floor trap. So this is the wet area and this is the dry area. Wet area in the sense the shower and water always will be there. So this is normally the toilet will be divided into one is the dry area and one is the wet area. So the drain pipe from the wash basin will be taken to the uh, floor trap. So whatever it may be, you don't connect directly to this manhole. Okay, so you have to take it to the initially to the floor trap. Then from floor trap only you will be going back to the manhole. Okay, so you can see here. See, from floor trap it is connected. From this floor trap also is connected and it is given there. And you can see another one thing. These both lines are different. See, this water closet line is separate, so this is a double stack system. This is a double stack system. Where the line is taken separately. So there is no connection between this line and this line. Right? So this is the soil waste line or the waste that is coming from the water closet. So the waste that is coming from the water closet is being taken through this and it is given into the this chamber. Okay, this collection chamber, not collection chamber, this soil inspection chamber or this manhole. Okay, so from there, this is the gully trap. You can give a gully trap. From there, you can give it to the wastewater pit. Okay, and the soil waste you can give it, you can take and you can give it to the government to the gully trap in soil pipe. You can give it to the septic tank and then to the soil pit. Okay, so from the kitchen also, you can take this line separately and you can give a gully trap here also and you can give it to the wastewater. Okay, so gully trap. Okay. So see the minimum diameter I have given for this kitchen is 63 kitchen waste pipe, and for this wash basin is 50, and this soil is 110. Okay, 110. So, so here I have given water closet minimum 110. Wash basin instead of 32, I have, as I say, if you are giving 32, also no issue, but I have given 50. Okay, normally the contractors will be mostly they will be suggesting about 50. Okay, according to the design, 32 might be enough. So, and one more thing, you can see here the floor trap. The floor trap normally 100 or 82 is given because this might be the inside diameter. So uh, outside diameter I have given 75. In India, which is 75 is there. So as NBC is 75 only. So from the floor trap, I have already said that here, from the wash basin it is directly connected to the floor trap. From floor trap, the from wash basin to floor trap, the dimension is 50. But from this floor trap, from reaching from this floor trap, you can see here, this is 50. From here, it is enlarging. This minimum, it should be 75. 75 should be the diameter. Okay. Anyways, after the after the floor trap, it should be 75. Minimum should be 75. Okay. So yeah. Now what we have to do is that we can deal with some questions. Okay. Let's see. Take to solve some questions. Or you can see here. Okay, one second. According to NBC, you can see the minimum pipe diameters here. According to NBC, the minimum internal diameter. It is inside diameter. Okay, so when you are trying to go and purchasing the pipe, it will be the internal diameter as well as external diameter. Inside dia and outside dia is there. For example, see this water diameter is, or this pipe diameter is 100. Why it is? Because 100 it is internal diameter. Outside diameter it will become 110. Okay, it will be 110 if it is outside. Okay, if it is outside it will be 110. Okay, that you have to keep it in mind. Sometimes they may say in 110, so sometimes they will be saying in 100 only. So when they give 100, it means that it is there denoting the internal diameter only. So 110 denotes the outside diameter. Okay, so the National Building Code of India, the minimum internal diameter for the sanitary appliances shall be as follows. So sanitary appliances are given, and with the minimum internal diameter waste outlet is also given in mm. So sanitary appliances, they have just separated into soil and waste appliances. Soil means from the water closet, or it can be as from the urinals also. Okay, depending upon that only, this is called a soil. And the next one is waste. So let's see what is the minimum internal diameter for different sanitary appliances. When it comes to soil appliances, you can see Indian or European water closet, it is minimum is 100 internal diameter. Bedpan washers or swabs, since it is 100. Urinal with integrated troughs is 75. Stall urinals with no more than 120 mm channel drainage, it is 50. Lift urinal, small and large, it is 40. So different types of urinals are there. According to that, the minimum diameters will change. Now coming to waste appliances, drinking fountain. Drinking fountain means it will be a tap or something like that. It will be minimum will be 25 mm. Okay. So wash basin 32, bidex 32, domestic sinks and baths 40, shower bath trays 40, domestic bathtubs 50, hotel and canteen sinks 50. Floor traps outlet diameter 65. So if it is an outside diameter, I will be giving 75. That's why I have given the 75. So when this wash basin is directly connected to this floor trap, from floor trap this will be getting directly 75. Okay, 75 mm will be the minimum pipe size from the floor trap. So how many wash basins are connected to this? The drain from the floor trap will be 75 mm. Okay. So regarding that, now we will be dealing with one. Let's see. We can deal with some question. We can solve a problem. Okay, before solving problem, it is said that the sewer drain shall be laid of a minimum of self-cleansing velocity of 0.71 meter per second. A minimum self-cleansing velocity. So normally the self-cleansing velocity is 0.75 meter per second. So for a sewer drain, what the NDC is stipulating is that sewer drain shall be laid for a minimum self-cleansing velocity of 0.61 meter per second and generally should not flow more than half full. Okay, should not go more than half full. So there is a half full and full flow. Half flow and full flow. Pipes are there. Pipes in the sense half flow pipes are there, and full flow is there. Full flow means we are considering that the water is completely filling the pipeline and it is going. Okay, that is called as full flow. Half flow means we got that only through the half of the pipes diameter is the water is flowing. First half will be secure, or let rest of the half will be leaken. So normally when it comes to drainage and all, we will be mostly deal with half flow, more than full flow. Okay, so for not getting any stuck or any blockage, better to give the half flow. Okay, so half flow pipes are usually recommended for drainage sewers pipes. Okay, so it is not an NBC 5.5, 3.523 clause. Okay, about the velocity. Okay, and should not flow more than half full. Now we are trying to deal a question. We are trying to find a question. Okay, and the question is find the diameter of the vertical stack. So listen carefully. We are going to find out the diameter of the vertical stack only. You know what is vertical stack, right? The pipe which is vertical. Okay. Find the diameter of the vertical stack in a 10-story building with the following number of sanitary appliances. So your aim is to find out the vertical stack diameter, not the horizontal stack, not the branch individual pipe. We are going to find out the vertical stack pipe diameter for a 10-story building according to NBC. So the sanitary appliances that are given there are water closet 40 numbers, wash basin 60 numbers, sink 40 numbers, urinal 20 numbers. So if you have this much fixtures, when you are trying to decide for your stack, for your vertical pipe, you need to know the size of the diameter of the vertical pipe. Okay. So for this, you need to know the fixture unit. Fixture unit. Okay. So you need to know the fixture unit. The fixture unit can be known from the National Building Code of India, table 23 of 6F. 6F. NBC table 23 6F. So table 23 6F. Okay. Yeah. You can take this one. Okay. Now, yeah, this is the fixture units for different sanitary appliances. Okay, this is according to National Building Code of India. Okay. Now, different types of fixtures are given here. One bathroom unit consisting of water closet, wash basin, and bathtub or shower stall. Okay, and the water closet, flush water closet. These are the different fixture unit factors given here. Okay, so what and all are there in our question? Water closet, wash basin, sink, and urinal. Water closet, wash basin, sink, and urinal. So water closet, we can use water closet depending upon the application we can use. Mainly we'll be having tank operator with the flush, correct? So the fixer unit for a water closet with the tank operator is for if you are using valve operator, okay, directly you can proceed. Valve operator. So Normally in our house and wherever we go, except in some public areas, we have water closet as uh, tank operated. So you can take this one. 4 is the fixture unit. And wash basin, how much it is? 1 is the fixture unit. Sink, domestic, it is 2 is the fixture unit. And urinal, stall is there, wall lip is there. Urinal, we can take this one. 4 is there. Both it is 4. So water closet 4, urinal 4, wash basin 1, kitchen sink 2. Okay. So for a 10-story building, uh, there are different numbers of water closet, wash basin, sink, urinals are given. And for individual wash basin, or for one wash basin, or for one kitchen sink, or for one water closet, the fixture unit is being given here. Okay. So give it from the table 23 of 6F, you know, you can get the value. How many water closets are there? 40. What is its fixture unit? 4. So multiply 4 into 40, 160. Wash basin 60 numbers are there. What is the fixture unit? 1. So multiply with 1, you will be getting 60. Sink how much? How much? 2. Multiply with 2, you will be getting 80. Urinal how much? 4. Multiply with 20 with the 4, you will be getting 80. You have to add all those things. So why? Because we are trying to find out the diameter of the vertical stack. We are trying to find out the vertical stack. So, so total, you know, it is 380. Total it is 380. Correct. So 380 is the total fixture unit for drainage. So now you go to NBC table 25 6H to find the diameter of the stack. Diameter of the stack for this fixture unit. So NBC table 25 6H. Table 25, 24. Yeah, this is table 25 6H. Okay. So here you can see the diameter of the pipe is given here in mm, and the maximum number of fixture units that can be connected is given here. Any horizontal fixture branch. This is about the branch only. Okay, this is about the branch horizontal pipes only, branch pipes only. One stack of 3 stories in pipe or 3 intervals. So you can see here. This is the one stack. This is the thing that we are dealing with. Okay. Table 25. Or I will show you this one. Table 25. You can see this one also. Maximum number of fixture units that can be connected to a single stack as per National Building Code of India are given in table 6H. Okay, this is the 6H. So diameter of the pipe is given. One stack of 3 stories is given. More than 3 stories is given. Total from each floor is also given. So depending upon the height of the building and the number of floors for each floor also, you can see the height diameter. So here it's a 10-story building. So 10-story building means this is not 3-story, it is more than 3-story. Okay, so it is more than 3-story. So what is our fixture unit? Our fixture unit is 380. Our fixture unit is 380. So go there and see where is 380. More than 3 stories, you can see 824 into 60. After 60, it is 500 only. So 380 is coming closer to 500 only. So if it is 500, what will be the diameter of the stack pipe? It will be 100. 100 internal diameter. So 100 is the pipe. Stack pipe. 100 is the stack pipe. Okay. Till 500. Okay. Till 500. If the story height is more than 3-story, we can give 100. If it was 1-story or 2-story or 3-story building, if it was the fixture unit was 360, you could have taken 540, and the diameter of the pipe will not be 100, it will be 125. It's for first 3 meters because this is more than 3-story building. The height is very high. we can take 100 mm is much, that is enough. Okay, that is enough. Okay, so yeah, we can take that pipe. Okay, so this is taken from the National Building Code of India. Okay, maximum number of fixed units that are connected to building drains and sewers are per National Building Code of India. So you got 100, right? So you can write the diameter of the stack is 100. So this is mainly depending upon the stack. Okay. Now from individual fixtures, from water closet, wash basin, sink, all those things, the diameter of the pipe will be minimum diameter, correct? Okay. From water closet it will be 100, wash basin it will be 32, sink it will be 40. That is the normal pipe diameter. You don't want any calculate for it. The pipe that is coming, the drain pipe that is coming from individual fixtures will be same because of what is given in the National Building Code. We don't want to calculate it. There are two or more things we have to calculate. Okay, so these things we have to keep in mind. So this is the horizontal fixture branch size. So if you are trying to get the branch pipe size, okay, find the fixture unit of individual fixtures, okay, add it, and then if it is coming in this range, you have to take that. If it is coming in this range, you have to take that. Okay, so let's see, is there any other questions? Let me see. Okay. Okay. Yeah. Another question. A five-story building has 10 water closets, 10 wash basins, and 5 sinks and 5 showers in each floor. Calculate the diameter of the horizontal drain. This is not about stack. Stack we have seen it, correct? This is about the uh, horizontal. This is about the this is about horizontal pipes only, branch pipes only. Okay, there will be branch pipe and there will be stack pipe. Correct? Just now we have found out about the stack pipe only. Now we are going to find out about the horizontal pipe diameters. Five-story building has 10 water closet, 10 wash basins, 5 sinks. From the individual water closet, it will be the uh, normal diameter of the pipe. Okay, I think that you haven't understood it seems. So I will say that once more. You have seen here, right? Indian and European closet minimum internal diameter should be 100. You understood? So for these people in your toilet, imagine in your toilet there is a water closet, there is a urinal, there is a drinking or wash basin on the shower. Okay, from individual fixtures, from these individual fixtures, the diameter of the pipe, drain pipe will be for shower it will be 40. For water closet it will be anyways it will be 110 or 100. Okay, for wash basins it will be 30. This won't change. So we don't want to calculate anything. We just want to look here. We just see what is the minimum internal diameter and go according to that. For example, you can see here water closet is 100. So that's why I have given 100 here. See, it is 100 or 110 outer diameter. Okay. So wash basin it was 32, but I have given minimum diameter of 50 for a safety. Okay. So I have given here 50. After the trap, which is normally it will be 65 or 75, correct? 65 is the internal. I have given 75 because of the outer layer. Okay, that's the thing. So if you are connecting this both the fixed unit of this plus this should be added, then only this pipe will be there. Okay, in that case the pipe size will change. We have to add the fixed unit. Okay, so let's see right now. Okay, let's see solve another one problem. So we will show you all these, different tables. Okay, from here itself I will show you. This was the question. So, table 23 is about the fixed unit. This table 24 gives the fixed unit values for fixtures based upon the fixed drain on trap size. Okay, different trap size are there, and depending upon different of trap size, the fixed unit value will change, because this floor trap is also acting as a fixture unit. Okay, there are 2 or 3 or 4 floor traps. For that also we have to add fixture unit. Okay, and then only we will be adding all the fixture unit. Then only the main pipe size will be sized. Okay, so depending upon different standard of drain pipes, the fixture unit also will change. Now, this we have already seen. This is the horizontal branch only. Depending upon these are the fixture units only. Depending upon the fixture units, if 160 is the fixture unit, 100 will be the horizontal pipe dia or branch dia. It's for a 3-story. The stack dia will be 100. If it is the fixture unit is 240. Okay. This is for more than 3 stories. Total for stack, total at 1 story or branch interval. This is for 1 story or branch interval. This much should be there. Okay. Now coming to this one, fixture unit values as load factor for various sanitary fixtures as per NBC is given in 6F. So this is the fixture unit value for different sanitary fixtures. Bathtub 3, bidet 3, kitchen sink 2, wash basin ordinary 1, water closet 4, the urinal 4, etc. This is the fixture unit. We have studied the water supply fixture unit, right? In the same way only, this also. Drainage fixture unit, but the fixture unit will be changing, okay, for this. Now the maximum number of fixtures that can be connected, this we have already seen. The maximum number of fixture units that can be connected to branches. This will be horizontal pipes only, okay? So the fixture unit is 1, minimum you have to give 30 mm. Okay? If this fixture unit is 3, 40. The fixture unit, if it is coming till 160, if the fixture unit is coming till 160, you can use 100 mm. Which means that for a water closet, the fixture unit is 4. Correct? If you are using half floor, you have to double it. Double the fixture unit. If it is a full floor, you can give this 4 itself. If you are giving the half floor pipe, you have to double the fixture unit. If this water closet is 4, you have to double it. You have to write it as 8. Okay, because of the half flow. You are considering that the water is flow through that pipe through half wave. Okay, so water closet you just right. Okay, water closet fixture unit value is 4. Okay, so imagine how much water closet will bring or how much fixture unit will bring 160. One water closet is 4. So 20 water closet, how much it will be? 20 into 4, how much? 80. Right? One water closet, the fixture unit is 4. So for 20 water closet, total how much? What will be the total fixture unit? 20 into 4, 60. So if you are using half flow, if you are using the half flow pipe, you have to double that. You have to double that. Okay? You can double it here or you can double after calculating. So if it is 20 into 4, 80. 80 double it will be 160. 80 double it will be 160. So for 160 it is 100, which means that 20 water closet, you can give 100 mm diameter. Okay. For 20 water closets, you can give main pipe size. After 20 water closets, you have to do 125 or something like that. Understood what I'm saying? If it is a half floor pipe. So the diameter of the pipe will be 100 mm. If you have water closet till 20 water closet. Okay, because the fixed unit of one water closet is 4. So 20 water closet it is 80. If you are using half floor, 80 into 2, 160. So 160 is the fixed unit. So for 160, what is the pipe diameter? 100. Okay. Now, this we have already seen that maximum number of fixed unit that can be connected to a single stack. Okay, this is a stack. So if the stack diameter is 30 mm one stack for 3 stories, you can give fixed unit 2 for this 30 mm. More than 3 stories, this is the fixed unit, and depending upon the different fixed unit, you can choose the diameter. This is total from each floor. Each floor, if 10 floors are there, 1 floor, 2 floor, 3 floor, from that particular floor, how much fixed unit can be given to 30? Only 1 fixed unit. Okay. So this is the collection system diagram only. This is just for your understanding only. This is the floor drain. This is from wash basin and washing machine. Okay, this is from the water closet and all those things. Access point is there. From there, it is connected to the a main sewer line, and then it is connected to the main line. Okay, this is the manhole. Okay, this is the public property. It is given to the public sewage after the manhole. Okay, so this is the stack pipe and this is the vent pipe. Okay. Now you can see from the house, clean out is there, underground sewer line is going and it is reaching to a manhole. And this is sidewalk. This much, this is for the home owner's responsibility. From here, it is municipal responsibility. Okay, till this much. For this, all these things, this municipal's responsibility only. Till this much, it is homeowner's responsibility. Okay, it will be connected to the municipal manhole. Now, this is the question that we already did. This one is fixture unit rating. Fixture unit rating, depending upon different fixtures. What is the discharge pipe diameter is given, minimum diameter is given. Okay, fixture unit rate is given. Fixture unit rate is given. Okay, and its maximum length of unvented pipe. So pipe difference length is also given. 2.5 meter is the maximum length that we can do. Okay, so here maximum number of discharge units allowed in stack. This we have already seen. Okay, 265. Depending upon that, diameter of the pipe is given. Okay, so maximum number of discharge units allowed in stack for more than 4 or more floors. This is 3 or less floor. This is 4 or more floor. Okay, depending upon this, the diameter of the stack is given. Okay, maximum discharge units allowed per floor and maximum discharge units allowed per stack. Okay, now we can do a question. A 5-story building has 10 water closets, 10 wash basins, 5 sinks, 5 showers in each floor. Calculate the diameter of the horizontal drain. Calculate the diameter of the horizontal drain. So a 5-story building, 10 water closet, 10 wash basins, 5 sinks, 5 showers in each floor. Calculate the diameter of horizontal drain. So this is used by fixture discharge unit loading only. So for water closet, they have taken from this fixture unit rating is they have taken 7. Okay. So fixture discharge unit loading method, water closet. How many water closets are there? 10 water closet what is a 5-story building? So 5 into 10 into 7 is the mixer unit. Okay, discharge unit. That's 6.8. Wash basin it is 1, sink it is 3, shower it is 2. So total loading unit is 525. So as a foul drain pipe sealer is to run half full, total loading unit will be. So when you add all those things, you got 525. So you know this drain pipe, if it's a stack, you can take full flow, no issue. If it is a horizontal pipe, you know you have to take half full loading. You have to run half full loading. So you have to double this. So don't forget that you have to double this. 525 into this 1050. So now you go to the page number 6E, page 24, 6E. Where is 6E? 6G. Same thing only, okay? 16. Okay. Number of fixture that can be connected to the fixture branch. Fixture branch. It is from NBC only, okay? So how much we got? 525. How much? Plus 1010 something, right? So it is coming 620. After that, it is 1400. So you can take this range, 1400 range. So the diameter of the pipe is 200. Okay, the diameter of the pipe is 200. Horizontal pipe diameter is 200. Let's see whether it is 200 or. They have taken us 1.25%. Okay, 150 is the horizontal drain they have taken. Let's see why they have taken 150. I think you can take 200. Okay, you can take 200, and they have given slope only. They have given slope of 1.25. So 6E, 6E, page 6E only, right? Yeah, this one only. Sorry. So maximum fixture units allowed in horizontal drain for full flow are given in 6C. Okay. So you can take here. So this is the grade in the sense this is the percentage. Okay, slope. This is the slope showing. So the 5%, 3.35, 2.5. These are the slope. And what is our fixture unit that we got? What is our fixture unit that we got? It is 1050. 1050. Okay. For 1050, we have to see how much is the pipe dia. Okay. For 1050, we have to see how much is the pipe dia. Maximum fixture unit allowed in horizontal drain for full flow. Okay, we have taken the double of it. Okay, so 1040. So 1040 plus 1050. 1050. So you can take 1050. See here. These are the different fixture units. Okay, 1050 will be coming in this range. Okay, 1050. You can take 125, or you can take better. We go for 150. Okay, you can go for 150, or you can see here. These are the different grades. Okay, so this is 5 grade means the slope is very large. So don't go for that. You can come less. Okay, come less, come less, come less. Okay, so you take this a slope of 1.25. You can take a slope of 1.25, or you can take a slope of 1.45. Okay, so 1050 will be coming in the range of 1040. Okay, so you can take 150 dia 150 of 1.25 slope, or you can take dia 150 of 1.45 swap. So we got the fixed unit as 1050, right? So it is coming very close to 1040. So you can take the diameter of the pipe as 150 and the slope is 1.25. And the slope is 1.25. This both are the columns of table 6C. Okay. So you have found the total units, loading units, multiply into 2 for the half front, you got 1050. Go to 6C of page 24, 6C of page 24. This is 6C of page 24. Select the fixer unit. Okay, there are different fixer unit. This fixer unit will be depending upon the grade only. Grade means swap. Go for a lesser swap and see for 1050 it is 150. Okay, 150 is the diameter. Okay, 150 is the diameter. So 150 horizontal drain sewer with 1.25 percentage. 1.25 percentage swap. Now we can see one more question. We can solve one more question so that you will be thorough with the swap also. Okay. Find the minimum swap required for 150 mm and 250 mm foul sewers running half full to have a self-cleansing velocity of 75 meter per second. So they are asking that you have to find out the slope of the pipe. And you found out that the diameter of the pipe is 150 and another pipe is 250. And the pipe is running in a half full form. And you need a velocity of 0.75 meter per second, which means that you have to find the slope in such a way that 150 mm and 250 mm, the velocity should be 0.75. Velocity should be 0.75. You have to find a slope depending upon 0.75 meter per second velocity and 150 and 250 mm diameter. Okay. Let's see how to do. We know we use Manning's formula for finding the slope, correct? Yesterday also we have seen that. So find the minimum slope of, this is the question. Find the minimum slope required for 150 mm and 250 mm foul sewers running half full to have a self-cleansing velocity of 0.75 meter per second. So as per Manning's formula, B equal to, this is the formula that you know. Diameter is 150 mm, it is given. N is, we know it, which is 0.013 roughness coefficient. Okay. So velocity is given, N is given, diameter is given. From there, you can easily find out S. So S raised to 1 by 2 is equal to 0.073. So S will be equal to 0.073 raised to 2. Okay. So it will be 0.00762. Okay, 0.00762. So this 0.00762 you can write as 762 divided by 100,000. Okay. So if you need to get in percentage, you just multiply with 100 here, you will be getting the percentage. You need to know the swap in percentage. We have seen the percentage, right? 1.25 and just before. So finding the swap, get this value 0.00762 multiply with 100 to find out the percentage. So you'll be getting 0.76 percentage. If you need to know the slope in fraction, like 1 is to 30, 1 is to 110, or 1 is to 150, 1 is to 200, what you have to do is that you have to divide this with, or you have to divide this number with 1. 1 divided by this, you will be getting a value. For example, imagine you got this value, this 0.00762. Divide with 1. Let's see what happens. Okay. 0.00762. Sorry, 1 divided by the answer. 1 divided by 0.00762 is equal to 131. You'll be getting 131. So the slope is 1 by 131 or 1 is to 131, which means that for 131 meter length, 1 is the slope. 1 meter is the slope. Okay, this is the way to find out the slope in fraction. Okay, this is in decimals. I think it is clear for you. Now, a slope of 1 by 131 is to be provided for 150 mm. See what to get X self-cleansing velocity of 0.75. Understood? So you have to give a slope of 1 is to 131. Okay. Now, for the diameter 250, what will be the slope? Okay, what will be the slope? For 250, same formula. Okay, just here, instead of this 150, put 250 there. Okay, and find out the S. And just divide 1 divided by 0.00384, you'll be getting almost 260. Getting almost 260. So 1 is to 260 is the slope, or 0.38 is the percentage. 0.38 is the percentage. Okay. So this is the way that we will be finding out the stack pipe size as well as the horizontal pipe size by National Building Code. Okay. So the first thing that you need to know is the minimum pipe size, minimum pipe drain size, constant with respect to different fixtures. Next one is you need to know the fixture unit. Depending upon the fixture unit, you have to add all those fixture unit, and you have to double it if you are trying to give a double flow. And with respect to that, go to the tabular column and find out which is the diameter for the corresponding fixture unit. Okay, this is the way that we will be doing the drainage also, drainage pipe size. And I have already shown you the diagram also. Okay. So, is there any doubt regarding this pipe sizing? We have taken this with respect to NBC only. Okay. Is there any doubt regarding this pipe sizing? Any doubts? No doubt. Okay, so we can wind up our class. I believe there is no doubt. So, we can see you tomorrow, and I will send you the video link. I believe that all the video links is been given to you. Okay. So thank you so much.